This paper is on Quantum MIMO, a framework for entanglement distribution in spatial multipath channels. My name is Akbar Saeed from Madison, Wisconsin. We all know that entanglement, distributing entanglement across transmitter and receiver is the first step for quantum communication protocols. So what we propose here is framework for distributing entanglement over multiple input, multiple output spatial channels. And we do it by sharing maximally entangled photon pairs over selected beams. And a lens array-based MIMO architecture is proposed for which is amenable to quantum communication, and some initial results are presented. So here's a description of a MIMO channel. So on the left is a transmitter array, lens array, right is another lens array, the receiver, and they're connected through this multipath propagation. This is the line of sight paths, and these are non-line of sight paths, which could be lossy or that could be engineered to have no loss compared to line of sight. And the lens array has a lens and an array on its focal surface, and the different antennas send beams in different directions. So it's an n-by-n channel matrix. So in the physical model, you can write it as propagation over the paths. For each path, there is an angle of departure at the transmitter and a corresponding steering vector, and at the receiver, a corresponding receive steering vector at the angle of arrival. And now we can also equivalently represent it by projecting onto the orthogonal beams, which serve as an orthogonal basis. And now these beam space channel coefficients characterize the channel, which is basically the projection of the channel onto a particular transmit beam and a particular receive beam. So how do we do distributed entanglement? Well, we first select n beams, and I'll talk about in a second. And then we have n qubit memory of the transmitter, n qubit memory of the receiver, and then we generate n maximally entangled photon pairs. And the first qubit is kept at the transmitter, and the second qubit is transmitted over a particular transmit beam, and then it is received over a corresponding receive beam. And the details you can see in the paper, but in the end, what happens is that the composite entangled quantum MIMO channel is basically you get all the chosen beams entangled through these entangled photon pairs. Now, why do we do beam selection? Because we want to achieve entanglement with minimum quantum memory. So we only select one receive beam for each transmit beam. And the results in the paper are basically we present for in terms of both trace metric and the mutual information, and I encourage you to read the paper. Thank you.